Hello everyone and welcome to another one of the GL Assessment homework reviews. Today we'll be looking at the maths homework from lesson number 8. Again, this is GL Year 5 Maths 5 lesson number 8 and I'm Luke Lloyd. So today this is the homework we're going through. It's the homework from week 4 and in this lesson we're going to go through the maths component. So that's this column here. And it comes from the Maths Quick Practice test book. And we're going to go through tests 10, 11 and 12. Remember, of course, guys, as we go through these, you can find all the answers in the back of the book, and you're welcome to use those in conjunction with these videos if you want any help. As we go through, I know that the clarity of some of these pages might not be 100%, so just remember as well to use the book in front of you to work along with me. Right, so test 10, you should have had 10 minutes for this. Please make sure you are timing yourself when you do these homeworks. It's really important so you get a proper sense of how you're doing to time. Of course, if you can't do something and you do run out of time, I would still recommend finishing the test. Being able to complete the maths is number one priority, but then we do want to start building in, getting used to the timer. And so just being aware of the time, if you're not yet at that 10-minute target, that's absolutely fine, just as long as you know what you're aiming for as an end goal. I think it's really important. Right, let's start going through the questions. So, which of the following does not, that's something I underline straight away, have a vertical line of symmetry? Well, a vertical line of symmetry is where you can fold it down the center and you have the same thing on either side. So if you were to hold your hands up to your face, you'd notice the thumbs are both pointing opposite direction. That right there is a vertical line of symmetry. In this case, B, I can see, does not have the line of symmetry because I would expect, for example, it to look like this with the B's facing opposite direction. That would have a vertical line of symmetry. So the B's are currently, they're all facing the same direction, and so B does not. Next question. Ben asked 48 children to choose their favourite chocolates, and he recorded his results in the table below. How many girls chose dark chocolate? Right, so we're obviously missing that fact. Where can we start using things? So we know that the total needs to add to 48. That's what the question tells us. So I think the best way to do this is simply to add up all the other options and then take away from 48 all the different ones. So you could do 48 minus all the rest of them, and that will leave you with, if we go through, I get one girl. And again, the way to do it, work it out, 48, start taking with, I take away the 8 first, that leaves 40, then maybe take away the 17, then the 2, then the 7, then the 3, to end up with one girl needing chocolate. So the answer is D. For number 3, a large plant requires 3.5 litres of water per day. So how much would it require in April? This is the second time we've seen a question that involves dates. So do make sure you guys know how many 30 days has September, April, June, and November. That's a great little rhyme that's often heard. So 30 days has April. That means we need to do 30 times 3.5. The way I'd recommend doing this is I would split it. So I would do 30 times 3, and then 30 times a half, which is the same as saying half of 30. I would work those two out. So in here we've got 15, here we've got 90. Put them together, 90 plus 15 is 105 litres. So the answer is A. Which of the following is not, again, before I think any further, going to jump out at me, not a cube number? A cube number, remember with a cube you've got yourself the 3 sides, or the 3 measurements. You've got height, you've got width, and you've got depth, the one that goes backwards. And so you need 3 measurements, 3 values. So a cube number is when you've got the same number multiplied by itself 3 times, and that's that height, width, and depth. So going through, I think it's probably worth learning, guys, your square numbers and cube numbers. Well, certainly a square numbers up to about 15 times 15, and cube numbers, I would say probably the first, I'd say 6 or 7 or so. I mean, ideally, if you can go all right the way up to 10 of 1,000, that'd be fantastic. As far as you can, it's just worth being able to recognize them. So cube number, cube number, cube number, cube number, which leaves D as not being a cube number. 161 is not. And again, this is just something worth learning in terms of what numbers you need to multiply. You've got 2 times 2 times 2, you've got 3 times 3 times 3, 4 times 4 times 4, and 8 times 8 times 8, if I'm not mistaken. Oops, sorry, no, 6 times 6 times 6. So, next page, number 5 and 6. the numbers in each row and column in the magic square add up to 12. So magic squares, you've got each direction add up. It's a bit like a Sudoku puzzle if you've ever done one of those. Sudoku is quite a nice little bit of practice, fun little warm-up activity that I would sometimes do. And again, I know people often need things to do. Not so much in their free time, but to fill the days, you want to keep learning, doing productive things during the day in lockdown. So I think Sudokus are quite a nice way to pass the time while again getting some practice in. So again, we know each row and column adds up to 12. So pick a direction that gives you two values. So I already know that these two right here need to add up to 12. So that's going to end up equaling 12. So in this case, what I'm going to ask myself, what am I missing? I'm missing 3. Again, in this direction here, going across here, what's in this square? Well, it has to add up to 12. So that's going to give me 7. So 7 plus what equals 12? Well, the answer is 5. And now I've got this row here where 7 plus 5 equals 12. So my answer E, I think, is 0. Now, again, with these Sudokus, we've gotten there in the most efficient way possible. In fact, we didn't even need to work out necessarily those, but I might just finish the square just to check, make sure that it works and I've not made a mistake. It's one of those balancing points where checking you got the answer right and wasting time. Certainly finish if I've got time left at the end, so I haven't used all my 10 minutes, just finishing off my magic square just to make sure, I think is probably a very good idea indeed. So let's have a check. So we need to do 2 plus 6 gives us 8, 8 plus 4 gets us to 12, and then 3 plus 1 gets us to 4, so we need 8 to get to 12. Let's just check in this direction, 0, 4, 8 does equal 12. So you'll see in every direction, all of these always adds to 12, and that's how the magic square works. But again, our answer was the missing space. So that's E, these two here. It's just a way of checking because it didn't take me too long. Number 6. What is the probability that a randomly chosen day has exactly 6 letters in its spelling? Well, for this one, it might be worth a time if you're not that confident with the spelling, listing out the answers, but the numbers, or the days that have only got 6 would be Monday, Friday, and Sunday. So that's 3. And the days in the week are 7. And again, depending how able you are with spelling, how familiar you are, you might be able to jump a state to 3 out of 7, or if you had to, you might want to write out some of the harder ones. Again, the way I think about it is, since day, that's a 3-letter word, is in common with all of them. In order to be a 6-letter day, you need only another 3. So mon, fry, and sun, obviously Sunday, whereas Wednes and so on, Thurs, they've got too many letters. So that's how I'd be doing that sort of more speedily in my head. Number 7. Which of these house names has a ratio of vowels to consonants of 1 to 1? For this, I'm definitely going to list out, I think, as we go through. The answer for this one, I believe, is marigold, because if we look, there are 4 vowels, 1, 2, 3, M-A-R-G-O-L-D, to 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, there's not. 3, 4, and I can tell, and you see how I've gone up, I've marked the top with my consonants at the bottom, so Roseville's looking pretty good to me. 4 to 4, double check, yep, I think the answer must be Roseville. And again, if there's time left over, I might just check, for example, then tulip, there's 2 up here, so 2 consonants and then 3 vowels, so that's not a 1-to-1 ratio. A 1-to-1 ratio, just to be clear, in this one would be a 4 to 4 ratio, but remember the ratios we can always simplify, and 4 to 4 is the same as 1 to 1. Could be simplified by dividing by both sides by 4. And again, you might just go through check, but the answer is in fact B, Roseville. Number 8, let's have a little look. So the weight of 5 children is listed below. Find the range. Well, range is the biggest measurement, take away the smallest measurement. So the biggest is here, 41.3 kilograms. And then the smallest is 29.5. Yes, it is 29.5. So all we have to do is take them away from one another. In this, I'll go through and just show you. So in this, we want to do 3 take away 5. We can't. So we borrow from the 1 to add to the tenths. So I've got 13 take away 5. That gives me 8. Put the decimal in the same place. I'm trying to keep everything in the same row. Again, oh, that should be a 0 there, sorry. Again, I have to borrow now from my tens. It becomes 30. Which means that becomes 10. 10 take 1 is 1. 1. So 118 kilograms. Or 11.8, 11.8 kilograms. Final answer. Number 9. £6.50 a week pocket money. How many weeks must he get to £52? So that's going to be essentially 52 divided by £6.50 is one way of getting there, probably the fastest. Or if you wanted to just keep doubling £6.50, you could also get there that way. But the number of times is, if we divide the two, you end up with an answer of 8. Now, I think possibly the way I would have done this, if you don't like the division with decimals, is I would have gone £6.50. I would have doubled that to get to 13. So I know that's going to be 2 weeks because I've doubled it. If I doubled it again, I'd get to 26. So that's now 4 weeks. And I would double it again to get to 52, which is now going to be 8 weeks. So if you think about the number of weeks it would take to double your money that many times, 4 times, so it would be going from 1, 2, 4, 8. So 8 weeks. So a couple of ways you can get there. I personally quite like that one with doubling, just because I can tell the numbers are quite close. But you can also just do a division. Right, the height of a wall is 937 centimeters. Round it to the nearest meter. So with rounding, I would set it out the same way. So to the nearest meter is this. So I draw an arrow above the number that may or may not change. The number that decides its fate is the number to the right. So I circle that number and I ask myself, is this number larger or not larger than 5? Well, 7 is larger than 5, which means the 10 will change. It will go up. And the rule is, once the rounding has taken place, all of the numbers become 0. So in this case, it's going to be rounded up to 100 centimeters, but that, of course, sorry, 1,000 centimeters, but that, of course, as we know, is the same thing as 10 meters. So the answer is B. So again, there's two things going on here. There's rounding, and then there's the nearest meter. I suppose you could have also you could have converted it first, so 9.37 with the conversion. Sorry, 9.73, get the right way around. And again, we're still doing the same question as before, which will still give us 10. So I don't mind, in this case, whether you convert first or round then convert, it's all the same. Right guys, that's one test done. So give yourself a score. Really well done. Oh, I should probably circle the answer there. That one was B, which is 8 weeks. But yeah, give yourself a score. Pat on your back if you did well done. Remember, any questions, you're more than welcome to come to the end of any lesson, and there we will go through a Q&A where you can ask any questions. We had a really nice one actually, where I think some of these questions were asked, people going through the homework. I think it was in test 15 possibly. I love the Q&As. The questions are really useful, really helpful. Obviously, the more people who ask questions, the better. And it can be quite a nice thing just to listen in on, because you might find out some things that you're going to either do on the homework that comes up, or some questions you wouldn't have known to ask, but actually found really useful. So guys, I realise this one's a little blurry, but hopefully you are using your copy of the book to read along with me. So test 11, again, it was 10 minutes. A rope is 5.07 meters long. It's cut into 3 pieces. Each of the 3 pieces cut in half again. What is the length of each piece of rope? So first thing we're doing is 5.07, and we're cutting it into 3 equal pieces. That means we are dividing it by 3. And then each of those pieces is cut in half again. So whatever the answer is, that answer will be divided by 2 to give us our final answer. So a few ways of doing this. I would probably do a bus stop. So let me show you a bus stop just in case people aren't sure. So 3s into 5 goes 1 time, remainder 2. 3s into 20, so make sure I keep my decimals in the same place. Whenever I can see that, I'll always put them there. 3s into 20, well, obviously 3 goes into 18 6 times, remainder 2. But 3s into 27 go 9 times. So the answer up here is 1.69. And then I need to do 1.69 divided by 2. Again, could do a bus stop again if you prefer, or you might want to do it mentally. With this one, if you're going to do it mentally, the way I would go about saying is, for example, well, the 9 is going to be split into 4.5, or 0.45, but remember this is moving down a place value. The 6 is going to be divided into 3, and then the 1 is going to be divided into 5, so I've got to add that to 3, so my answer is going to be 0.845. Oh, and there it is. And so just have to think about the units it wants it in this case millimeters. That's going to be 8.45 millimeters. But again, if you don't like doing it mentally, absolutely no reason why you couldn't do the good old-fashioned bus stop Lots of people don't like to use bus stop when it comes to decimals for some reason, but as you see, it just works exactly the same way as long as you remember you always keep your decimals in the same place. So anyone struggling, I would draw this out for me and have a go at filling it in and see how it ends up. And what you'll see is you'll get 0 times 8, 4, 5, but you'll probably have to do, you'll have to go down to here and you'll carry the 1 onto the 0, and that's where that 5 comes from. Anyone who wants me to show it, by all means come to the Q&A. Right, number 2. The table shows the performance of the Holden Cricket Club over the spring and summer. How many matches did they not win? Well, not win is lost and drawn, so it's going to be these numbers added together. So the way I do that is probably 3 and 7, which gives me the 10, plus 6, 16, plus 5, 21. And again, this is the kind of jotting I might expect you to do if you are doing things in your head, but you want to keep track of the maths you've done in case you do get distracted. That's perfectly reasonable to do just a little bit of jotting. I'm not expecting full working out for these questions. I'm expecting the amount of working out you need to get the answer, which is a slight difference to the usual maths lesson, because I realise on these that just time is so important that you mustn't waste it. If you can get away with saving time and still get the answer, you should. Train ticket to Broadstairs Beach costs £24.50. 25 people. How much money do they pay for their train ticket in total? So again, this is a multiplication. I've shown this before. People sort of have all sorts of ways of doing these. This to me smacks of something I would do as what we call the lattice multiplication. So if I draw this in, actually to be honest, it's only 25, so I can probably get away with not using that bottom part. I like to make sure it's squares. So you draw yourself it's called lattice because you draw a lattice, you draw this grid. And then 25. And you just need 1 for each number. You'll notice I've missed out the 0, but that's because I know for 25.0, the point there isn't necessary, although I'll make sure to put it back in because it's important for money, not so important for calculations. And then you divide across like this. And this first part is just the setup. The next part really is the maths, and let me show you how it goes. So you do 5 times 2, gives you 10. 10's go on top, units on the bottom. 5 times 5, 25. Keep going, 2 times 4 is 8. 2 times 2 is 4. 2 times 5 is 10. Just make sure your 4s are like 4s. Your 1s don't go diagonal. 4 times 5 is 20. And now what we can do is add down our diagonal column. So this is 5. This is 2. 8 plus 2 plus 1 is 11. So I write the 1 of the units there and the 1 that we've carried up here somewhere. And then I've got 4 plus 1 plus the 1 that we carried, 6. So now my answer is 615. But here's the really cool method and why I like this one. Whenever you've got decimals, so let's pick a nice colour. Remember this is 25.0, so the decimal will be here and here. You can find out where to place your decimal by following the line to this diagonal where they meet. And this diagonal tells you where the decimal place goes. So I can see that my decimal goes 6, 6, 1, 2.5. I then suddenly remember it's money, so I add my 0 back in, and that's my answer. And that's why I like the lattice method. People sort of say, oh, well, that's a new method, that's different. That's why I like it, because it's good for decimals. But again, if you're really comfortable with the grid method, the column method, whichever one works for you best is the best answer, is the correct one. So that makes B my answer. And if you want to see some videos on that, you can type into Google the lattice method or Chinese multiplication. It's a good little trick to learn. I like it very much. Number 4, a book has 520 pages. 25% of the pages in the book contain illustrations, drawing. How many do not? Okay, well, there's a couple ways of doing that. So it's 75% do not. So I want to know 75% of 520. A couple ways of doing it. I could work out 25% and take that away from 100%. So I could work out what a quarter is and take away from all of it. I think the way I'm going to do it is I'm going to actually work out what 50% is. And the way I would do that is I would halve my number. So 50% of 520 is going to be half of 520. So that's going to be 260. I'm going to work out 25% of 520 by halving it again. because to find a quarter of something, we halve it and halve it again. Because if you look, well, half of 50 is 25, so whatever half of 260 is will be my answer, so that's 130. And if I now want to know what 75 is, well, if I add 50 and 25, I'd get 75. So if I add my two numbers here together, I get my answer of 390 pages. Makes my answer C. I think that's the nicest way. Again, splitting your percentages up into easy to work out ones that you can add together to work out a more complicated one, I think is your best method. So I wanted 75, so I worked out 50 and 25 and added it together. Great method. Question 5, part B. Oh, sorry, question 5, the answer is B. You've given the game away, but let's go through and talk about why. The graph below shows a location of 4 places. Which place is shown at the coordinates 8, 7? So the important rule here is you go along the corridor and up the stairs. And really, you've got to remember, and this is, we're only dealing with one direction, but actually the rule is you go along in any direction and then up and down the stairs, if we're being really, precise, which I do like to. So you go along the corridor and you can go in either direction, left or right, and then up or down the stairs, up or down. But either way, it means you've got to go along to 8 and then up to 7, which means L is my coordinate and L is Will's school. And so if I was writing it, I would mark here 8-7. So the first coordinate is across, and then the second coordinate is the up or down. Right, number 6. Let's have a little look. The water jug holds enough water to fill 8 glasses. Which of the following is the best estimate for the capacity of the water jug? Oh, I like this question. So this is an estimate question. For these, I'm probably going to go through, try and picture things in my head and eliminate. So right off, I know how much a litre is. A litre is your sort of standard drink. It would be your standard bottle of orange juice, for example, from the shops. So 220 litres, well, that seems like far too much. Milliliters, that jumps out to me. Milli, meaning sort of milli and mini, sort of in my mind, means very small. So in fact, the 20 and the 1.5 milliliters is very tiny. I mean, 1.5 milliliters would, I don't think that would be less than that. Would be a tiny little teaspoon or less than. In fact, even 20 milliliters. I think if you ever had one of those Calpol spoons, those special sort of slightly deeper ones, which have a little bit of a trough, I think they're sort of 10 mils maybe. So 10 mils, somewhere between sort of 1 mil and 10 mil is the smallest baby teaspoon for like cooking, and sort of 10 mils might be a normal teaspoon. So again, those are definitely too small. Then I need to have a look. 1.75 litres or 17.5 litres. Well, again, I'm coming back to, I'm using things I know that a normal bottle of water might be sort of half a litre. And I say one of those big, sort of one of the things you buy in the supermarket of orange juice, that might be about 1 litre, maybe a little bit more. So I think, and if I think about how many glasses of juice I could get out of those, probably a good 3 or 4 or 5. So I think 17 litres is still too big. 1.75 litres is right for me. This is going to be, guys, one of the things you just have to learn, but it's probably worth just going through and in your heart, in your mind, being able to visualize, imagine what is a gram. What would something be that weighs 1 gram? 1 kilogram, 1 ton, 1 litre, 1 milliliter, 1 milliliter. In the same way you can probably picture in your head roughly what a meter is and what a centimeter is, you should have that same understanding for the sort of basic units, and the distance, volume, and weight are obviously the most common units that we use. In the same way you'd know how hot something is 100 degrees hot, or is 0 degrees cold. You would know these things. It's worth making sure you know this for the other values as well. Just estimates. Number 7. Ronnie ate 2/7 of his chocolate buttons and left the remaining 15. So how many were there in total? Well, he ate 2/7, which means there were 5/7 left. And it's saying that the remaining amount was 15. So that means 5/7 is 15. With me so far. So if 5/7 is 15, what would 1/7 be? I'm going to need a bit of working out space. I'll get rid of my little slightly crude drawings. Bring this over here. So 5/7 equals 15. What would 1/7 be? Well, you've got 5 lots of something or 1 lot of something. Well, 1 lot is going to be 5 times smaller. Hopefully you can see from here to here, from 5 to 1 is 5 times smaller. So I'm going to have to do the same thing and work out what is also 5 times smaller. 15 divided by 5 is 3. So 1/7 is 3. Okay, well then what would 7/7 be? Well, how much bigger is it? It's going to be 7 times bigger. So my answer is going to be 3 times 7, which is in this case 21. So we had 21 sweets to begin with, which I've got to say is a pretty good number of sweets. Number 8. In a decade's time, Jean's age will be her third of her father's age. Right, golly gosh. So I like to start with these with a little grid. And I like to write down all the people. So we've got J for Jane and F for her father. And we've got N for now. And we've got then in a decade's time, so that's 10 years' time. So I'm going to write sort of 10 years' time. So first off, I want to see what information they've given us. So Jane's age now, well, we don't know. In a decade's time, it will be a third of her father's. Her father's current age is B. Oh, they haven't given us enough to fill out the other two, so maybe it is an algebron. So her dad's age is B. In a decade's time, so that means in plus 10. Ooh, tough question, this one. So Jean's father's age in a decade's time will be B plus 10. Because he was B, but in a decade's time, he'll have gained 10 years. And then Jean's age will be a third of her father's. So B plus 10 is going to be a third of this. Because it's a third of whatever that age will be, which is dividing by 3. So B plus 10 was her father's age in 10 years' time, and her age will be that divided by 3. So that's equals to her, to Jean's. Yeah, I should really write it here. So her dad's age is going to be B plus 10, and her age is B plus 10 over 3. So what will her age be now? Well, it's going to be this age minus 10. Because to go from here to here is 10. So this age, in this missing bit here, will be B plus 10 divided by 3 minus 10. Oh, that's good. Well, now we can see which one that matches. So B plus 10 divided by 3 minus 10. Oh, so I think the answer is A. So guys, with this one, bit of a confusing question to start with. I had to sort of go through it step by step. Just go through the steps again. We start with B. Her dad's age is B. That's step 1. Next, it says we work out that it's in a decade's time. So her dad will be, whatever he was, B, plus 10. So that's when we worked out this part. So this is the father in 10 years' time. Then we work out that then when her dad is B plus 10, she'll be a third. So she'll be divided by 3. So this was step 3. And then the final step for us to think about is, okay, well, what is she currently? Well, it's going to be her age in 10 years' time, obviously minus 10, which is where our step 4 came for. And this is what goes in here. Obviously, there's not quite enough room for me to write it. Cool question. I love a good algebra like that, where it really makes you think. Right, number 9. The function machine below divides by 7, then adds 10. Okay. What is the output for the given input? So we put in 1085, and it's told us it divides by 7, and whatever that answer is, that answer will have 10 added to it. Okay, let's get to it. Oops, sorry, I've written it wrong though. Divides by 7, I wrote down 10. That's why it's always worth double checking. Right, let's get to it. Again, for me, I'm going to jump straight to a bus stop. So 7's into 1, don't go. 7's into 10, go 1 time, remainder 3. 7's into 38, go 5 times, remainder 3. 7's into 35, go 5 times. So 155. And then 155 plus 10 is 165. So it's C, final answer. Woohoo! Next up, I'll show you it was C, 165. And the last question, guys, doing really well. 2/3 of the way there nearly. The table shows the number of cars and the number of passengers in each car that passed by Rope Street in one afternoon. If a pie chart is drawn, so immediately pie chart, what facts come to mind? The format's going to be 360. Let's find out if that's useful. I'm not sure. If a pie chart is drawn to represent the number of cars, what angle at the centre of the pie chart will represent the number of cars with 2 passengers? So I'm going to mark off 2 passengers. And it's going to be the number of people, or number of cars I should say, sorry, is 20. But it's 20 cars out of how many? If I'm going to work out what fraction of the pie chart, and you've got to remember guys, fractions, decimals, percentages, they're all linked. So if I know what a fraction is, I know what the decimal is, and I know what the percentage is. So there's going to be 20 out of this total. So I'm actually going to take a moment just to add these up. So 30 plus 20 is 50. 50 plus 10 is 60. 60 plus 12 is 72. So plus 3, 75. So it's 20 out of 75. But I don't want to know what it's going to be out of 75. I want to know what it's going to be out of 360. Now, there might be a way to get there in one go. I think the best way probably, let me just separate that. The best way is to go via an intermediate step. So I want to get to 360, but I can't think of any way to multiply 75 that makes 75 times 4, for example. That doesn't get you to 360. So I'm going to try and find an intermediate fraction where I can times multiply the top and the bottom to get a fraction that I can then easily multiply to get to be 360. So let me have a think. What could I do? Well, if I simplify it down to being out of 15, because I know that 15 goes into 75, I can then get from 15 to 360, because I know my 15 times table is up to 360. Another way of thinking about it might be, if I doubled 15, that would be 30, and from 30 I can definitely get to 36, so if I can get 3 to 36 would be the same difference as 30 to 360. So let's just go through. How did I get from 15 from 75? Well, 15 divided by 5 gets you to, 75 divided by 5 gets you to 15. So I need to do the same thing on this fraction. 20 divided by 5 is 4. So again, so far, my fractions, they're just equivalent. I've not changed the fraction. I've just changed its form, how it looks, but it's still the same value, essentially. So now I need to think, well, how am I going to get from 15 to 36? Well, a couple of ways of doing it. You could say, the way I'm planning to do it is, if I times it by 2, I'd get to 30. And then times 30 by 12, I'd get to 360. So what's the same as timesing by 2 and timesing by 12? Well, that's the same as timesing by 24. So 4 times 24 equals 96. And again, so timesing by 4, double it again. So 48 and 48 doubled is 96. Final answer then is not 96 out of 360, but it would be 96 degrees. Because that's what that degree symbol actually means. That degree symbol means out of circle, out of 360. And there's my answer. Right, guys, doing brilliantly. Oh, so we're going to move on to the last activity. I'm just going to quickly find the page for us. And here we are. So, test 12. Let's go through it again. I'm sure you know we're 10 minutes, 10 questions. We'll run through them, do the answers, and see how we go. So mark along with me. Remember, guys, as well, one thing is just worth pointing out, if you do find things hard and you have struggled and you haven't got things right, that's absolutely okay. But my advice is one of the ways to sort of go back and get the maximum use out of these is, by all means, follow along with me now. Maybe actually go through and copy out my answers so you can see how the working out flows. Think about how each step fits together to get you the answer. Leave it a few days and then revisit it. And you can revisit the questions, maybe not on the same piece of paper, but get a fresh bit of paper or rub out if you wanted to. So you're looking at the questions again, and that's really going to let you get the most value out of these things. It's just something that's worth mentioning. You can do the same questions again if you're still not quite getting them until eventually you can do them. And that's brilliant. You've learned something, you can move on and tackle new questions. But there's no point just constantly throwing yourself new questions, if you're not going through and being able to master the old ones and make sure you're really comfortable with the hows, whens, and whys. Right, so let's actually start answering the question. So squash is made by mixing mango juice and water at a ratio of 1 to 7. So that means in total I'm going to have 1 bit of juice, 7 bits of water to make 8 units in total. And then how much water is there in the squash? Well, there's 7 parts squash out of 8 bits water. Sorry, let's say it again. 7 bits water out of 8 parts squash. That makes more sense. But the point is it's 7 out of 8. So we want to know how much is 7 eighths of 2.5, 2.5. 7 eighths of 2.5. So with this, the key thing to remember is we are multiplying by the top and dividing by the bottom. So we could choose to times by 7, then divide by 8, or vice versa. I'm probably not going to divide by the 8 first, because I think that makes it a bit more complicated. I'd much rather multiply by the 7, because if I can to avoid small decimals, I'm going to choose that route. So let's times by 7 first. Let's do 7 times 2.5. The way I'd probably do that would be 7 times 2 and 0.5 times 7. So 7 times, so I've split the 2.5 into a 2.5, into a 2.5. So 7 times 2 is 14, and then 0.5 of 7, 0.5 of 7 is going to be 3.5, which means the total is 17.5. Right, last thing for us to do then is divide that 17.5 by 8. So let's write it out as a bus stop. So 8 dividing into 17.5. I have a feeling we're going to have some decimals here, so I'm just going to extend my bus stop preemptively. 8 into 1 go 0 times. 8 into 17 go twice. Decimal, always put a decimal in the same space. Now there's a remainder, and that remainder is 1. So now we've got 8 into 15. 8 to 15 will go 1 time. Remainder 7. Now I don't have anywhere to put that, but remember I can always add in as many zeros after decimals as I need. So now 8 into 70. Well, 8 times 8 is 64. So it goes in 8 times, and the remainder between 70 and 64 is going to be 60. Sorry, 6. And then I add a 0 to get my 60. And then 8 into 64, well, 7 times 8 is 56, so it goes in 7 times. And then the remainder between 56 and 60 is 4. And then finally, 8 into 40, because again I can just add as many zeros as I want. 8 into 40 goes 5 times. So my answer is 2.1875. Just got to remember, of course, that that is litres of squash, but I don't want litres, I want millilitres for my answer. So a quick conversion where I just move it, again, if I'm timesing by 1,000, I move it the 3 zeros, 1, 2, 3. So that's where my decimal will end up. So let's write it out, 2,187.5 millilitres, which should match with 2,187.5 millilitres. So the answer to the first question is E. Right, next page. Let's have a read. Each time a ping pong ball bounces, it reaches a height equivalent to 60% of its height on the last bounce. So we're doing 60% each time. The table below shows the height reached by the ball after each bounce. What number should replace the question mark? So in each one, we're losing 60%. So I want to know what is 60% of 180. I think the easiest way to do that is to work out 50% and 10%. 10% is divided by 10, so that's 18. 50% is half, so that's 90. Put them together, and I'm going to get myself 108. And I'm just going to read the question again. It reaches a height equivalent to 60%. So it reaches a height of 60%. So that's my answer. If it was losing that much height, I might have to take it away. But no, if it reaches a height, I'm happy. That's the number I'm after. Which means the answer is 108. Number 3. What's the area of the rectangular carpet below? Well, I know in area it's base times height, so I need to do 6 multiplied by 4/5. And as I already said before, we're multiplying by the top, dividing by the bottom. And again, in this case, I think I'm probably going to multiply first because it'll make my answer a bit easier. Because I'd rather avoid decimals wherever possible. So let's do the multiplication first. That's going to be the same thing as saying 24 divided by 5. And I might just take that over here and do a little bust. Sorry. Yeah, 24 divided by 5. And let's say, good old-fashioned bust up, I think. So now 24 into 5. So 5 into 2 goes 0 times. Into 24 goes 4 times, remainder 4. Put the decimal in, put the decimal in. And then 5 into 40 goes 8 times. So it's 4.8 meters squared. I've got to be very careful here because the answer is not in meters, it's in centimeters. And when converting between meters squared and centimeters squared, perhaps this is the best way to demonstrate it. Meters squared means meters times together. That's what meters squared is. So the way I like to think about it is if I was to convert each of my meters to centimeters, that would be, so instead of having 1 meter times 1 meter, which is meters squared, I'd have 100 centimeters times by 100 centimeters. And that would end up with the same as centimeters squared, meters squared. So in order to convert between meters squared and centimeters squared, it's not times by 100, but it's times by 100 twice, which catches a lot of people out. So the correct answer is, if I move my decimal place, 1, 2, 3, 4, going to be 4, 8, 1, 2, 3, 48,000. And that will catch a lot of people out. If you're not confident as to why that is, something I suggest you do as a practice, you're thinking, Mr. Lloyd, you've gone crazy. Let me show you. If you did, let me rub out some space. Let's rub out up here. What answer would you get if you converted it to centimeters first? So I'm telling you that the answer is 4,800. Hopefully some of you agree with me. But if you were doubting, let me just show you. If instead of 6 meters, you did 600 centimeters, and you multiplied it by 4/5 of a meter, which you're going to have to just trust me on that, is the same as 80 centimeters. What answer do you get then? The answer will come out in centimeters squared. I have a feeling that your answer is going to be very similar. In fact, I guarantee it will be, because it is the same. Right, next page. Let's just circle it. There's B. Number 4, a metal cube with a side length of 50 centimeters. And actually, can I just say, for that last question, the more I think about it, it probably is easiest, because this doesn't look like too hard of a multiplication. It might be easiest to do the conversion first. So if you're not happy with multiplying by a fraction, and you're not happy doing a quick conversion first, and then multiplying together, I think that actually might be the more efficient route. And since I'm all about efficiency, now that I've thought about it, there's nothing wrong with doing that first and getting your answer that way. Right. A metal cube with a side length of 50 centimeters is melted to make smaller cuboids, each measuring 4 centimeters by 3 centimeters by 10. Okay, so a cube with length of 50 centimeters is going to be 50 by 50 by 50. We know this about volume, and funny enough, the same point I was just telling you is going to happen again, but this time instead of going from squared, it's going to be cubed. So it's going to be 50 times 50 times 50. So that's the volume, which is equal to, oh my goodness, we were banging pots and pans. It must be 8 o'clock on a Thursday. How nice is that? So 50 times 50, it's going to be the same as 5 times 5, so 25, but going to be with the two 10s added on. And that multiplied by 50 is going to be as 25 multiplied by 50, which is going to be 125, but with 1, 2, 3 zeros. So the volume of my metal cube that I started with is 125,000 centimeters cubed. And I want to make it into smaller cubes that are 4 by 3 by 10. So 4 times 3 times 10 is going to be equal to 12 times 10, which is going to be equal to 120 centimeters cubed. If I now take my large shape of 125,000 and divide it by my small cube, I can work out how many times the smaller cubes will fit, and that'll give me the number of cubes. So for this, right off the bat, I can make it a little bit simpler, cancel my tens, but I've still got, not the easiest in the world, I've got to do 12 into 1, 2, 5, 0, 0. Now, if this because we're dealing with actual objects, any decimals, any remainders, I'm just going to write as remainder because I don't need to know how much they'll make because it's not going to make an exact cuboid. So 12s into 1 go 0, 12s into 12 go 1, remainder nothing. 12s into 5 go 0, 12s into 50 will go, and they'll go in 4 times, remainder 2, and then 12s into 20 go in 2 times, remainder 1. So I'll get exactly 1042. No, I won't. It will go in 1041 times, because of course 12s into 20. I'm sure you were shouting at the computer screens, and 12s into 20 go 1 times. Remainder actually much more, but 1041 is my final answer. It nearly caught me out. 1041. And again, the remainder, although there will be a remainder, we don't really need to worry about what it is, because of course there won't be anything to do. In fact, it'll be remaining 12 and 20, 8 over, well, be into 80, but we don't need to worry about that because it's not a whole cube. Right, for number 5, let's have a look. Figure B consists of a regular pentagon and a triangle. What's the size of angle X? So I need to know some rules about my triangles. First off, that is looks to me like a right angle triangle. I also know that all the angles in my pentagon are going to add up to 540. So if I do 540, because it's a regular pentagon, if I divide 540 by the 5 angles, I'm going to work out the size of my angle. And 540 divided by 5 is going to be 100 and, no, yes, 108. So there's that with my rubber. Because 40 divided by 5 is 8, and 500 divided by 5 is 100. So each of these angles, I'm just going to draw the one I need, each of these angles is 108 degrees. And now hopefully you can see in here, this line here in red is a straight line. And there's a rule about angles in a straight line and what they have to add up to. And the rule is angles in a straight line must equal 180 degrees. They add up to make 180 degrees. So if this green part, I should be very careful with that line because it's a bit over. So if that green part is 108, the remaining part must be 180 minus 108 to find out what's left, which is 72. So the missing angle X is 72 degrees. That's quite good. I thought I might need a right angle, but no, didn't even need it. We could get straight there. Right, number 6. What is the value of A? So let's write it out. First step, my rule with this is always to move the smallest value of A onto one side. In this case, it's the -5, so I want to move that and get rid of it. I'm going to add 5A to both sides. And that's going to result in this. It's going to result in 12. These cancel out, being equal to 6A minus 12. Now I want to get my A on its own. So I'm going to get rid of the -12. To get rid of something, I do the opposite. Add 12 to both sides. 12 plus 12 is 24. Being equal to 6A. And now last step, I want to get the A on its own. So I've got to remember that 6 is timesing the A. I want to do the opposite, so I'm going to divide both sides by 6. Then that means on the left-hand side to show you, we have these cancelling out to give you A is equal to 24 divided by 6, which is 4. So A equals 4. Number 7. Which of these facts is true? There are no right angles. Well, no, there is. It's a right angle triangle. It says it's a right angle triangle. So I think that one sounds good to me. There is only one acute angle. Well, acute angles are less than 90, and if that is a right angle, which it must be, both of these have to be less than 90 degrees. So both of these are acute, so it can't be that one. Angle A is obtuse. Well, obtuse means more than 90 degrees, and we can't have that because we can only have one 90-degree triangle, because I know all the angles have to be, all they have to add up to exactly 180, and I've already got 90. I can't have one angle being more than 90, so that's false. Angles A and B are both acute, yes, because they both have to be less than 90. The smallest, for example, this one could be 89, and this could be 1, and that would work. It wouldn't look like anything like this, that particular triangle, but that could never be more than 90, because if it was, of course, it wouldn't work. It would be a square. So I found my answer. Just to check, none of the above statements. Well, no, I found one that is. Number 8. Which of these numbers does not give a value of 10.3 when rounded to the nearest tenth? So again, I'm going to work out. This is my tenth. The 5 would round it up, 10.3. This is my number. The 4 would round it down, keeping it as 10.3. This is the number I'm rounding down. And yes, I am, because it's a 1, so 10.3. This is my number here. That's what I want to round. So there's tenth. The 9 will round it up, 10.3. Which means my answer is E. And why is it? Yes, because this is a round number I'm rounding. The 5 is obviously means this rounds up, 10.4. Easier one out. Number 9, the table shows the number of children who participate in different activities at school. Basketball is the most popular activity. If the range of children is 22, how many play basketball? Oh, that's a cool question. Well, most popular, I mean, this is the biggest number. Whatever it is, it's going to be largest. And range is biggest, take away the smallest. So if I find the smallest number, and I add to it the difference, so I take the smallest and I add the range, I will get the largest number. That means the largest number says 33, and is that the largest number? Yes, it is. So my final answer is A, 33. And that's about range being the biggest, take away the smallest. So I went in reverse. 33, take away 11, does give us the range of 22. So I can just check out there. All right, last question. Oh, this is a cool one. So this is a timetable of Brighton railway station. Ali reaches the station at 2:36. So he's got here just after this train, 2:36. Assuming the trains are running on time, what's the earliest time he can reach Haywards Heath? Well, he walks in at 2:36, so it means he's missed the 2:35 train. So the next train that's leaving from Brighton, you'd have to go to platform 2, and he'd have to get on this train, which is the 2:43, and the 2:43 takes 20 minutes to get there, and it will arrive at 3:06. So he would arrive at 3:06. So guys, that's a really cool question, and that's just about understanding how train times work. So this is something that you can absolutely do online if you wanted a bit more practice. You could just sort of look up, work out what time, if you to pick your local station. So for me, it'd be something like, I don't know, Woking Station. I'd work out if I wanted to get from there to Guildford, what time train would they arrive? But essentially, if he's arrived after, just so you know, I might as well go through it. This is the time the train arrives at each station. So the time that this train arrives at Brighton, the time that the same train will arrive at Haywards Heath. But obviously, if you want to know what time you're going to get to one place, that's the same as it arriving at that place, so long as you're on the train. So in this one, because he arrived late, he missed this train. So each one of these separate block is a separate train. So this is his train. This one. It's the first one he can get. And so he gets on the train, travels down the track, and when it arrives at Haywards Heath, that's the time. Yeah, if you're not sure, Mum and Dad, I'm sure, can help you with this kind of thing. Pick out some examples and sort of give you a little bit of a quiz and see if you can work out what times things would arrive. Right, guys, that means we've reached the end. Really, really well done. I hope it's been useful. Again, any questions, please do come to the Q&As. Chris and I are happy to go through questions. I've had some great questions from people popping in, some lovely bid mass questions, all sorts. It's been really cool. One thing I will just highlight as well, as all the sessions that are obviously on, these guys, these are the game sessions. Have been really good, really fun. Chris has been doing them every morning. They're open to everyone. You find them on the main Teach It Right Facebook page. That's the main one where all the posts come through, not other than the private group. If you're not sure, just send us a message on the Facebook group and we'll point you in the right direction. And it's really great. 45 minutes. It's quizzes, it's puzzles, it's fun and games. It's more of the stuff we'd like to do in the Teach It Right lessons, obviously, but that we haven't necessarily been able to do because of the restrictions that have been put on us. But again, we would love everyone to come down. Please do and make the most of it, as well as making the most of all these Q&As that we always finish the sessions with. Right, everyone. Thank you so much. See you all next week. Bye bye.